So the next topic is electrolysis of acidified water using platinum electrodes. So why do we call it acidified water? Because pure water or distilled water, although it is a polar covalent compound, it cannot conduct electricity. Because whatever ions are formed, that is hydrogen ions and OH minus ions, it is not capable of transferring electricity. Hence, we have to add a few drops of acid, sulfuric acid preferably, so that water becomes acidified and hence it can conduct electricity. So this is the procedure. So why do we only add dilute sulfuric acid? See, it is given in your book too. Dilute sulfuric acid is preferred because it is non-volatile. Non-volatile means that it does not evaporate easily. But the other acids like HCl, HNO3, that is nitric acid, and hydrochloric acid, all these are quite volatile. They can evaporate easily. Therefore, we use sulfuric acid because it is non-volatile in nature. So the electrodes used in this case are platinum electrodes. Like I told you that there are two types of electrodes, active and inert. In this case, platinum will act as an inert electrode. It will not take part in the reaction. Also, as you can see in the figure, the electrolytic cell looks a little different. It is like a tube-like structure. So water is placed in the center tube, and on one side we have the cathode where hydrogen will be produced because hydrogen is a positive ion, and on the other side oxygen will be produced. Since oxygen forms a negative ion, it will be formed in the anode side. So why such a tube-like arrangement is done? So that we can understand the formation of the gas. Because if it was just a beaker or something like that, we would not understand if a gas has been released, because both hydrogen and oxygen are colorless. In yesterday's video we saw that bromine was released in the anode region, but since it was colored we could understand. But in this case, since both the gases formed in this reaction are colorless, therefore such an arrangement is done. Next is why the dissociation of water, or why the breaking of water into its constituent ions is known as catalytic procedure when sulfuric acid is added. So what happens? Why is the sulfuric acid added? Because I just told you that distilled water is a non-conductor of electricity. So in order to increase its conductivity, sulfuric acid is added. But none of the sulfuric acid is utilized in the reaction. They do not take part in the reaction. So there are certain substances which do not take part in the reaction but which help the reaction to proceed. They are called catalysts, right? Therefore, the process of dissociation of water into hydrogen and oxygen is also known as catalysis, a process which uses catalyst. So what are the ions formed in this reaction, and which one will move to the anode and which one will move to the cathode? Let's see. So whenever acidified water is ionized, that means ions are formed. The first ion formed will be from the self-ionization of water. Water, if it is mixed with water, it will always self-ionize. You don't have to do any other procedure. It will just start self-ionizing. So H2 will form H plus ions and OH minus ions. This is a topic of the second chapter. And H2SO4, since it is an acid, the first ion it will be which it will form will be H plus ions. We are not writing H3O plus here because we are not considering the reaction of water and hydrogen ion. We are not forming hydronium ion. We are just forming hydrogen ion. So H2SO4 is breaking into hydrogen ions and sulfate ions. SO4 2 minus ions. So what we can see that there are two positive ions present in the solution. Both are hydrogen in this case. But there are two different negative ions formed in this case. One is OH minus and one is SO4 2 minus. So according to the electrochemical series which we learned in the previous video, sulfate is above hydroxide in that series. As a result, obviously sulfate will not go first to the anode. OH will go first to the anode. And since there is only one type of cation, so that will directly go to the cathode. So what are the reactions in this case? What are the reactions at the anode and at the cathode? We are going to learn. Okay, so now let's see what happens at the cathode region and what happens at the anode region. What are the reactions? So again, I would urge you to write the reactions along with me so that you have a better understanding of the topic. So at the anode, obviously the OH minus ions are going because they are the negatively charged particles, and at the cathode H plus ions are going since they are the positively charged particles. So what happens at the cathode? Let us see first. So H plus ions are going out there. So as you can see, H plus ion has one electron less in it. That means one electron has to be added. So one electron is added, and on addition we are getting hydrogen atom H. This is an arrow. Hydrogen atom. We are getting hydrogen atom. But as you know, hydrogen cannot exist as a monoatomic gas. So this hydrogen atom will react with another hydrogen atom and it will form H2, hydrogen molecule. This is what happens at the cathode. Initially hydrogen ions were going out there, but since hydrogen ion has one electron less, it is taking one electron and it is getting converted into hydrogen atom. Since hydrogen atom cannot exist like a monoatomic gas, it will combine with another hydrogen atom and convert into H2. Now let's see the case in case of anode. So one OH minus ion is going first to the anode. So since it is a negative ion, that means it has one electron extra, right? So it will lose one of its electrons and it will become OH. But OH is not any molecule, right? It cannot exist like this. So one OH will react with another OH and what will form? See, there are two H, so H2. From here one O will be taken, so H2O, water will be formed and the other O will remain. So H2O plus O. Now this oxygen again cannot exist like a monoatomic gas, so this oxygen will combine with another oxygen and it will form O2. So as we know, water is composed of hydrogen and oxygen. So in the anode side we will get oxygen because it is a negatively charged, it will form a negatively charged ion, and on the cathode side we will get hydrogen since it can form a positive ion. Now what happens, as we know that H2O means there are two atoms of hydrogen for every one atom of oxygen. The same thing is maintained in case of electrolysis of water also. We will learn about this in detail in the next part of this chapter.